Hello friends, welcome back to my YouTube channel. I am Spandana of CSE department studying at Sri Venkateswara College of Engineering. Today I am going to discuss a topic that comes under the subject computer networks. Contents that we are going to discuss. Firstly, let's see what is fragmentation of network, and let's see two different strategies used for fragmentation of network. First, let's see what is fragmentation in network. Fragmentation is an important function of the network layer. It is a technique in which the gateway break up or divide the larger packets into smaller ones called the fragments. The larger packets are divided into smaller ones. These smaller ones are known as fragments. For dividing the larger packets, we require a gateway to break up the larger packets into smaller ones. Each fragment is then sent as a separate internal packet. Each fragment is as its a separate header and the trailer. This process becomes necessary when the size of the original data exceeds maximum payload that a network can handle, or when the network has varying maximum transmission unit sizes along its path. The fragmentation and the reassembly process is typically performed at the network layer of the OSI, that is Open System Interconnection mode. There are two different strategies for the recombination, or we can say reassembly of the fragments. Now let's see two different strategies for the recombination of the fragments. First one is transparent fragmentation, and second one is non-transparent fragmentation. Now let's see transparent fragmentation. This fragmentation is done by one network is made transparent to all these other subsequent networks through which the packet will pass. Whenever a large packet arrives at the gateway, it breaks the packet into smaller fragments as shown in the figure. That is, the gateway G1 breaks a packet into smaller fragments. After this, each fragment is going to address to same exit gateway. Exit gateway of a network reassembles or recombines all the fragments as shown in the figure. The exit gateway G2 of a network 1 recombines all the fragments created by the G1 before passing them into the network 2. Here there are two networks, network 1 and network 2. Each network has two gateways, that is G1 and G2, where the packets get enter and exit through these gateways. Suppose the large packet is entering into a G1. The function of the G1, that is gateway 1, is to divide these packets into a smaller fragments. Here G1 divides the packets into a smaller fragments. These smaller fragments again passes through G2. Here the function of G2 is to recombine or reassemble all these divided fragments and forms the packet. It recombines all the divided fragments or the data, and it forms the one large packet before passing them into a network 2. Here same process take place in the network 2. This large packet get passes through G3. Here the fragments are formed, that is G3 divides the packets into a smaller fragments. Again these fragments is recombined by the G4, that is exit gateway. Exit gateway will recombine all these smaller fragments into a packets. So this G4 will recombine or reassemble all these smaller fragments and forms the packet before passing it to the another network. The subsequent network is not aware that the fragment has occurred. This type of strategy is used by ATM networks. There is two types of networks. One is transparent and non-transparent. The subsequent network, that is network 2, will not be aware that the fragmentation has occurred in a network 1. This type of strategy we called as ATM networks. These networks use a special hardware that provides a transparent fragmentation of the packets. There are some disadvantages of transparency strategy, which are as follows. Exit fragment that recombines fragments in a network must known when it has received all the fragments. Some fragments chooses a different gateways for exit that results in a poor performance. It has a considerable overhead in repeatedly fragmenting and reassembling of the packets. Now let's see what is non-transparent fragmentation. This fragmentation is done by one network. It is non-transparent to the subsequent networks through which a packet passes. Packet fragmented by a gateway of a network is not recombined by exit gateway of a same network as shown in the below figure. Once a packet is fragmented, each fragment is treated as an original packet. All the fragments of a packet are passed through exit gateway, and recombination of these fragment is done at the destination host. As in non-transparent fragmentation, one network is made as non-transparent with subsequent to the another network. But in transparent fragmentation, we were making one network as transparent with subsequent to the another network. Here, network 1 will be non-transparent in non-transparent fragmentation. Here the packet passes through a G1. The function of the G1, that is gateway 1, is to divide the packets into a smaller fragments. As these smaller fragments get passed through a G2, that is gateway 2, the function of the G2 is to recombine these fragments again to form the packets here. But in non-transparent fragmentation, G2 doesn't recombine all these smaller fragments, all these fragments again into a packet, and instead it passes this fragment itself into another network. It doesn't recombine this fragment. G2 doesn't recombine this fragment. But in transparent fragmentation, G2 was recombining all these fragments and it was forming the packet again before it passes through a network 2. But in non-transparent fragmentation, G2 doesn't recombine all these fragmented data, and instead it passes as it is into a network 2. Same, these fragments are passed through G3, and these fragmented networks get passes through fragmented data gets passes through a G4 until it reaches a destination host. These fragments are not recombined or reassembled again. When it reaches a destination host, the destination host will recombine these fragments. Here, each fragment has its own identity, or it is treated as a original packets. Let's see advantages of non-transparent fragmentation. We can use a multiple exit gateways and can improve the network performance. Here we can use a multiple exit gateways, that is G2. Whereas in transparent fragmentation, we cannot use a multiple exit gateways because their exit gateways performs the functions like reassembling of the smaller fragments. Here in non-transparent fragmentation, the exit gateways doesn't perform any function, just it passes the fragments itself into another network. It doesn't recombine any smaller fragments. So the network performance also increases and it also has a higher throughput. Disadvantages of non-transparent fragmentation: every host has a capability of reassembling the fragments. In transparent fragmentation, the G2 has a capability of reassembling the smaller fragments. But in a non-transparent fragmentation, every host, that is destination host, has only a capability of reassembling the fragments. When a packet is fragmented, the fragment should be numbered in such a way that the original data stream can be reconstructed. Here, when the G1 divides the packets into smaller fragments, each fragment, that is individual fragment, should be given a numbered so that at the last it can reconstruct the data stream. Total overhead increases due to a fragmentation as each fragment must have its own header. And this was all about the fragmentation of the networks. And thank you all for watching my video.